And someday when we're back together in person, they have a booth at all the international meetings. So I want to define genealogy and forensic genealogy as well. Genealogy is the study of identity and kinship, and forensic genealogy is the study of identity and kinship as it pertains to the law. So just a short introduction of where I'm coming from. In 1976, I started my first serious genealogical research. My mother-in-law left a little note on a coffee table, and it's very, very old, from the 1870s or so. It said, when the twins were born, their heads were so small, they were incubated under teacups. And I did a double take. I was only like a month married, and I was finding out now that there were twins and triplets in the family. So this really launched me into a career I wasn't expecting. So back then, if you wanted to prove something genealogically, it meant you went somewhere like a courthouse, or you went and you interviewed people. It's a very different way from these days. It was also harder to prove something because there weren't really standards of proof that were well known. There have been standards since 1960, and they get more complicated all the time, but a lot of people don't know about it. There is a genealogical proof standard that has 5 elements in it and 84 standards you have to meet, but very few people know about that. So nowadays, it's almost like just clicking a button and you get a lot of answers. Those of you who are familiar with GEDmatch, which is a DNA database for autosomal DNA for people who are trying to find ancestry and friends and family and solving mysteries. This is their automated cluster tool, and it groups people in different ways. Maybe they share more centimorgans, which is call it a unit of measurement. The bigger the centimorgan shared, the closer you're related. And you see each one of those clusters that look like boxes or not. And those are people who are related to you in the same way. And you just let that run, and all of a sudden you're looking at people automatically in a very easy way. And their names and their kit numbers are on one side and at the top, and I've got something like 25 clusters there that I could work on, that each may represent a certain branch of my family tree. So it's not all that simply done, but in just a few.
Curious what application that is that you were just in.
That was called gedmatch.com.
Okay.
GEDMATCH. I have their logo on a later slide. So you can also benefit from the millions of people who've put up family trees, and the trees look like this. All you ask for is Henry Mahoney in this case, and you give the year of his birth or death, so you can sort him out from all the other Henry Mahoneys in the world. And you get a chart like this. Now, it might not be correct, but there's a lot of clues there. And in that center column where it says sources at the top, those are things you can look at that will either prove or disprove what the people are saying on the left column and or the right column. And I always go for the ones where there's a photograph, because if you've got a photograph of somebody, there's a connection that gives a little more veritas to what you're saying. Otherwise, who knows where the people's sources come from and whether it's right. So these days we use a host of online sources, many more than were available just last year, honestly. GEDmatch is down there in the left corner. Um, we'll see some more things from that later. But DNA Painter right now is one of my favorites. You get your saliva or cheek swab processed for autosomal DNA, and you can go to DNA Painter, and no matter what company you did your test with, you can make a painting. I'll show you that in a minute. Been verified, and people finders help us go through the donut hole where a lot of records aren't open to the public, and people finders will give you information that's drawn from things like driver's licenses and other sources, people who are born after the last census that's available, things like that. And you can get quite a lot of detail filled in if you use all these websites that are listed here. You can solve a lot of American problems with just what's there. So we were talking earlier about, I guess it was Lynn and me before we started, about World War II. I think all of us know about Rosie the Riveter. When the men went to war in World War II, the women stepped up and went into the factories and did the work the men had done. Well, it's the same thing for scientists. When all these male scientists cleared out and went to war, somebody had to do the algorithms for the bombing sites and other technical mathematical things. And the call went out for people who were really skilled and also happened to be women. And most of the women that answered the call were single and very young. And they all congregated at the Edward Moore School of Engineering just outside of Philadelphia, where they did this work for about 2 years. Later, some of them went on to work on ENIAC, the first American computer. And you see to the far left, there's a woman who appears to be of color. And 2 twins in that picture recalled that her name was Alice Hall, and that she didn't live with them in the dormitory on the college campus, and that she had been like a leader in the group. She's quite a significant mathematical genius. A professor at Temple University wanted to track Alice Hall, but had for years tried and could not find her. And this is one of my 10-minute solutions. I knew exactly where to look, in what order, and found her living just outside of Philadelphia. Actually, she's deceased at the time I was asked to do this. And it was just using regular genealogical sources. I found her. I found that her niece wrote a spectacular obituary for her. And she had lived to be over 100 years old. I just missed her. It really kills me that nobody asked a genealogist who could have solved this problem. But my secret to finding her in the first place, I put in Alice Hall into the 1940 census. In the 1940 census, they asked what was your highest educational experience. So some people had a 5, so they got to 5th grade. In the case of 2 women of color of this approximate age, named Alice Hall, one of them had a C4, 4 years of college. And she lived outside of Philadelphia, close enough to the Moore School to commute. She had a son, however, and none of the other women, as far as I can remember, were married. but they had said she might be married. So we went back to the twins and they said, yes, she had a son at that time. So that solution led to a screenplay that may finally someday appear as a short television series. So genealogy can do stuff like that. It can also do stuff like this. The woman in the middle of this picture pushing the dark colored stroller jumped from a train in 1942 that was headed for Auschwitz. And she was the source of a manhunt for 2.5 years before she was caught. She survived the war. It's an incredible story. She had one child, and by tracing people from the town, she returned to the town where she had her son, and she and her husband lived for 2 years before it became untenable and they went to Palestine. The woman to her left has been identified by a child survivor who is now in her 80s that had pictures also of this group of people. And this was all done using genealogical techniques. So for what I do in the most recent reincarnation of my career, the forensic genealogy is something that's been badly needed for a long time. You'll remember right around the 1990s, right here in Florida where I am, the courts started accepting DNA evidence, and now they're starting to accept DNA-based leads that lead to identifications. But it's not as new as you might think. Since about 2004 or 5, there have been several people who've been knocking on law enforcement's door and saying, we could solve this case if you'd share the DNA. We can do this. Let us show you how to do it. And these genealogists mostly got treated like psychics, but more recently that's been a better response. And here are some of the very earlier cases that were solved before the very famous Golden State Killer. On the left is the Frank Van Zandt case. This is a man who was born in 1911. He was on a plane that crashed in Alaska in the 1940s, 1948. And they found everybody else, but they didn't find him. And a pilot from the same group that this tragedy occurred to went back again and again, year after year, and he finally found a hand in the snow. So genealogist Colleen Fitzpatrick, who's a PhD physicist, said, okay, I can solve this with DNA. And in a very roundabout way, she used mitochondrial DNA from that hand to find an Irish cousin who matched in a proper way. And they were able to give him his name back and count him as deceased in 2008. Also in 2008, one of my students at Boston University solved her mother's parentage. Her mother had been adopted and knew it and wanted to meet her birth parents. It was for her mother's 60th birthday, and there was a big party. The mother and father were both deceased, but there were some aunts and uncles and lots of cousins and some full siblings as well. So one of the full siblings took my student Corey aside and she said, you know, you've done a great job finding us. I know you can find Mary Alice. Would you please find Mary Alice? Mary Alice lived in Los Angeles. She disappeared one day on her way to work when she was about 23 years old. left the house, never came back. Her parents lived in the house for the rest of their lives, waiting for her to come home. They were both gone, but this aunt had not given up hope for her turning up. Mary Alice was last seen outside of a police station where she had reported her purse missing, standing on the front step and using a mirror to signal down the street. The end of that street, a group of Black Panthers were robbing a bank in which the security officer was killed. And that's the last time Mary Alice was ever seen. So using genealogical search techniques, going in a spiral from the last place she was seen, Corey reconstructed all the likely paths, and she finally found a Jane who had been dumped in a adjoining county's drainage ditch. And she called up the police department. She got a detective. She said, this case, she was found right after, she had found the case in a newspaper. She said this person was only a day dead when she was found stabbed 40 some times. Do you have pictures from the crime scene? And the detective said, yes. She said, would you pull them? And they were very interested in solving this case. So he pulled the almost, well, it was a very old case, 30, 40 years at that point. And they pulled it, and she said, is there a mole on above her lip? And the detective looked carefully and he said, well, it looks like dirt, but yes, there is. And she says, well, this person otherwise matches a missing cousin of mine. Would you do DNA? And they said yes. They did have DNA, and they did test the aunt and several cousins, and they got a triangulation, and it is indeed Mary Alice. And that was a first for this student, but not her last. The case that really turned the corner for law enforcement to start believing in genealogical techniques and DNA evidence is not the one you think it is. This is the Bear Brook serial murder mystery. Bear Brook Park is in New Hampshire, where I lived for some 30 years. And these are 3 of the 4 victims found in 2 oil drums that had been dumped on the Bear Brook Park lands. And it was believed to be the most awful group of unknown dead women in the country. And people have been trying to solve it for a really long time. I had been teaching at BU for a number of years in 2017 and teaching a Jane Doe case that turned up 6 miles from my house, but about 15 years before I even moved to New Hampshire. And I could not get anywhere with law enforcement. So I finally, knowing that they wanted to solve this case, I went and I briefed the attorneys general and the cold case unit, which is very small, and some state troopers about what could be done to properly solve this case. And I then was asked back again, and I brought a mathematician from Newfoundland, and we presented all kinds of information. They gave us no information back, and I finally realized why. The deal was, if I told them about this, they would read me in and give me a non-disclosure agreement to tell me about the Jane Doe I was trying to solve. turns out that they were at the same time talking to a person in California who was a geneticist and a search angel. Search angels are people who do help folks who are looking for their birth parents or their birth children. And she had been asked to help find little girls' parents. This girl was dumped at a trailer park in California by a guy that she thought was her father. She had grown up, she was in her 30s, and she saw Skip Gates on the PBS program about finding your family roots. So she, the girl, grown up, called her local deputy and said, hey, could they do this for me? And the deputy was familiar with her case, connected her with Dr. Barbara Ray Venter, and Barbara had solved this case. The news that this case had been solved didn't really hit national airwaves, although it was out there if you were looking for it. But Paul Holes, a detective in California, learned about Barbara Ray Venter's success, and he went to her and he asked her, can you work on this case? Now, she had never wanted to work on dead people's case. She wanted to do the search angel route, but she recognized how important this was, and she agreed to do it. When the news came out that she was using GEDmatch and Family Tree DNA, which are both databases of genetic material where people compare and can see other people's matches to themselves, not their DNA, but the spots where they match. A small group of about 4 people got really incensed and started quite a revolution. And those databases were closed in May of 2019. All right, so they were reopened under different terms of service. And now, in order to use these for law enforcement purposes, the DNA first has to be run through CODIS. That's a different kind of DNA. Those are STRs. Ours are SNPs, single nucleotide polymorphisms. It must be a case of sexual assault, violent assault, or murder. It can also be for unknown dead, which is something that I'm trying to push harder on being returned to the normal access. It has to be in a database that gives test takers the option to refuse law enforcement or allow it. And so going from 3 million kits to compare to about 1.5 million, and none in the GEDmatch at all on that day in May, to the present day, we now have about 1.5 that we can look at. And it's believed that there are close to 40 million people who've taken the tests, but they're in databases where the company that runs them does not give the test taker a choice to allow law enforcement access. In fact, some of them won't even accept a lawful warrant. So that's the situation. What this DNA, the autosomal DNA, has done for us is to allow us to work 5 generations up from somebody and 5 generations down from somebody. And your genetic tree is different from your genealogical tree. You've got to have all the people that are in the genealogical tree. But by the 5th generation, you are losing a complete person or more just by the the natural and random nature of recombination in your DNA as fathers and mothers get together. So that's a 9-generation span, which is very powerful. So I told you I'd show you about DNA Painter. This is what it looks like. I got 45 or so people that are represented there. On the far left, those little round circles that you can't really see, that's the number of the chromosome. So there's 22 chromosomes listed there. And then the 23rd chromosome is your X chromosome. And a lot of these results don't include the X. So you paint in color an individual's match on the person that you're studying. So say this is me. Some of those people are going to be first cousins. Some of them will be second cousins. Some of them will be third cousins once removed. The smaller the block of color, the more distant the relationship. And some of those people may not even be related, because this combines both sides of your strand of DNA. And you might be matching on one strand, but I have it on the other strand. So it's a false match. All right, so you can see that in DNA Painter, very useful. Also, there are a number of calculators that'll tell you if you count up the centimorgans, and like I said, that's a distance. The bigger the number, the closer you're related. But your centimorgans have to be in clusters of at least 7 to be valid. Otherwise, it's just chance. All right, so 139.92 centimorgans with a longest segment of a certain amount. We can't see that, it's under the screen. And a certain number of segments will give you a second cousin once removed, or a third cousin, or half first cousin once removed, all these possibilities. And that's the real trick to this. You need to find out which of those categories this person belongs to. So I go about it in a very procedural way. I first check to see what someone's origin is. So the person you're looking at here has 63% European origin. A lot of it's United Kingdom or Central Europe, and 30% African. A lot of it is Nigeria and South Africa. And then a small 2% mix that's Morocco and southern Spain. So with that information, I know what to expect, and I can give law enforcement an idea of what the person might look like from what their genetic makeup is. According to the genealogical proof standard and most accepted standards, we need to do 5 generations back of every person we're looking at before we can jump to the conclusion that my Joneses over here are the same as your Joneses over there. So people who do mirror trees and just match by looking at surnames need to do this, because there's a sneaky little thing called endogamy, where if you have somebody in your ancestry who married their first cousin, or even a little bit more distant, you're going to see some very different results in percentages, and people will look like they're more closely related to you than they actually are. So in order to understand what your results are, you need to do this 5 generation. And sometimes that's not possible for a lot of reasons. So here's an example of what I send to law enforcement after I've solved a case. Usually they can follow the diagram better than my verbal discussion. So your green box is the sample, and in this case, he's solved. He's the guy that they gave me DNA to work with. The people who are in yellow are the people who were test takers. These are people who either spit in a vial or who had a cheek swab, and they put their results either testing with family tree DNA or putting their results on GEDmatch so that I could see them. Now, the people in black, ordinarily, if you're trained in medicine or anthropology, this would indicate that somebody was dead. In this case, this is for privacy reasons. So I'm not showing the police necessarily who these folks are. I am telling them who these folks are, but they don't necessarily know the full identity. I mean, you are more than just your name. You could have the same name as a lot of other people, so consider that. So the people who are in triangles, these are people who have not allowed law enforcement to see their results. And I will not under any circumstances show them to law enforcement. I get kicked out of the databases, and I would end my usefulness as a genealogist if I did. I also do this for anyone who is a member of the European Union, because they have a law that's called the right to be forgotten. And I cannot report who they are to anybody else. They can.
Sorry to interrupt you. I just wanted to let you know we're actually at time. So I wanted you to
I'll do this very quickly then.
Awesome. Thank you.
Run it right through. At any rate, in order to solve this one, I had to go from these two test takers and find this person. I had to go through this test taker and find this couple and see that these two come from the same couple. This is a triangulation, okay? And they also match this person. And I had to figure out which of the many people that it could have been who have that same relationship this person is. This is the holy grail of charts. It's where there's test takers on mom's side over here, and a test taker on dad's side over here, and also over here. And that's a perfect triangulation. It showed me that only somebody who matches this and this person and descends from these two people can be our candidate. And in this case, there were two people. It was not the first person they tested, it was the second. I guess I don't really have time to show you this. I was going to go through the ethical considerations, but they are many and tangled. So my opinion is it the truth? Yes, no question. Is it fair to all concerned? Yes. If you believe in justice, if you believe it's right to name somebody who's unknown, dead, and can't be identified any other way, yes, this is the right thing to do. And I am honored to be able to do this for people all over the country. And I want to suggest to you, be like me, be interested in how this can be applied in your own neighborhood. I did not know that there was a Jane Doe that died in 1971, found in 6 miles from my house, until I went looking for one to teach the BU class. And it's extraordinary that that sort of tragedy could happen right in your own backyard and you wouldn't know about it. So stand up for somebody who's been forgotten. Take a look, see if there's such a case. Ask your local police. They'll know. And thank you.